So question 32 is testing whether you understand the log function or the exponential function. Exponential function, that means if y is equal to a power of x, let's say, or maybe 2 power of x, then the graph will look like 2 power of 0 give you 1. So when x is equal to 0, the height is 1. 2 power of 1 give you 2, 2 power of 2 give you 4, 2 power of 3 give you 8. So it will be increasing when x become 1, 2, 3, and 4. And then it's not the same speed, but going faster and faster. This is exponential graph. Okay, so the reverse is logarithm. So you imagine that you rotate this line and this, not rotate, you flip the red line and the blue line. You are changing the input and output. So red line flip to this position, blue line flip to this position. That's why the logarithm will become reverse like this, and this is the reverse. So this is y is equal to log 2x. Log 2x is like this. So if I try to use the graph to present the idea, this is the graph. It's exactly the same as we flip it and then we rotate it to assume x-asset is at the position of y, and then y-asset is at the position of x-asset. So this shows you how they are related. But if you flip the asset, it's no longer the same position. This line is y equal to a power of x, and this line is y equal to b power of x. So first we look at the shape of this graph. This curve is increasing. That means if we keep multiplying more b, it will become bigger and bigger. Multiply something to become bigger, that implies that b is larger than 1. Similar reason, this curve is also increasing. We keep multiplying, the number will finally become bigger and bigger. So a is also larger than 1. But if we compare which one is larger, quicker, then you may just check. If we multiply by a larger number, then it should be go up faster. That means this curve go up faster earlier than a, which implies that b, the base number, is larger than a here because it's go up faster. Or some other method is some of you will add a reference line here, and then we compare this line is b power of, maybe this one is 3, let's say b power 3. Then this height is a power 3. It's because b power 3 is higher than a power 3. b power 3 higher than a power 3, so b is larger than a. We may also compare in this way. So b is larger than a. So we find that the first statement is correct, while the second statement is wrong. Should be b larger than a, not a larger than b. So the last part is about AB. Compare AB with BC. By using our understanding in function, we may, this one is 1. Basically, we should let this one be x0 or some other unknown. But for simplicity, in MC, we just find any number larger than 1. So if I say it is 2. AB is more difficult to find, but BC is easier to find. BC, that means the corresponding height here. So when y is equal to log bx, we are considering the situation when x is equal to 2, then the corresponding height is log b2, which means this length is log b2. Similar reason, if we consider this line, y is equal to log ax. When x is equal to 2, then y is equal to log a2. So this line is log a2. Our mission is compare AB with BC. So we want to find AB first. AB, that means the longer line minus the shorter line here. So that means AC minus BC. We just continue to calculate. This is log A2 minus log B2. So that means this is, we may just stop here first. And then after that, how about if we consider BC together? So our conclusion, AB over BC is equal to log A2 minus log B2, and then divided BC is log B2. Simplify that, log A2 over log B2, separate the fraction, and then this one numerator and the denominator are the same, so this will become 1. They are not the same base, so we have to change this to log 2 divided by log A first. The denominator, log 2 divided by log B. So we can simplify this part, and then it gives us log B divided by log A, and then minus 1. That means log B over log A divided by minus log A divided by log A to create the same denominator. Log B minus log A, and then this is log A. Finally, this is log B divided by A and divided by log A. So after that, we may change this one to be the base. That means log A and then B over A here. So after so many calculations, we find out the last statement, oh my god, is correct. And then the first one correct, the second one is wrong. So our conclusion is C in question 32.